Bismillahirrahmanirrahim. Hello everyone. I'm Hassan, and in this presentation I will be covering the findings of the case study that I have done for the course Electrical Machines offered at Habib University. For my case study I chose synchronous brushless DC motors or BLDC, and in this presentation I will be first covering the introduction followed by the construction of the BLDC, and then we will look at the working principle, characteristic equations, and then a few applications and uses of BLDC. So BLDCs were first invented in 1960 and were formally developed with advancement in the solid-state electronics such as computer drives and DVD players, because in these peripherals a very efficient motor drive system is required, which does not lose its efficiency with the passage of time, as is the case with a normal DC motor. In normal DC motors, we have a process called commutation, which is defined as switching of polarities through contact of brushes and commutators. This process can reduce the life of the motors and can also cause sparking in certain cases. Devices such as computer peripherals and DVD players operate at a very sensitive level of voltages and cannot allow such actions of commutation or sparking to affect the sensitivity of the device. Thus, BLDC avoid this kind of commutation through elimination of brushes, which increase the life and reduce the maintenance cost of the motor. BLDC employ a mechanism of control feedback system, which is the process of controlling the motion of the motor through various sensors for the feedback. This mechanism helps BLDC provide faster response or dynamic response, that is to basically control the response of the response to the control signal provided to the motor. Moving on to the construction of BLDC, we have total of 4 major components in this motor. The rotor consists of permanent magnets with pole pair ranging from 2 to 8. The magnet in the rotor is usually boron, ferrite or cobalt to provide a strong flux density in magnet. Next, we have the stator, which consists of steel lamination with various copper windings wrapped around them. The placement of the winding is such that it actually cuts the boundaries of the stator, helping to uniformly distribute the flux in the motor. These windings can also be configured into delta or star configuration depending upon the type of the BLDC being employed. For this presentation, I will be discussing 3-phase synchronous BLDC. So apart from that, the next thing we have is the Hall sensor, which detects the position of the motor, and feedback control, which is basically the signal that is looped back through the sensor. This signal helps switches the polarities of the windings of the stator to make the rotor turn. Now moving on to the working principle of the BLDC. It works on the fundamental principle as any other DC motor, that is current carrying coil in presence of magnetic field will face some kind of force on it, which is called Lorentz force. This force will cause the rotor of the motor to turn. The commutation in BLDC take place in segments or sequence. We have usually 3 Hall sensors that detects the position of rotor. The total of 3 coils energizes and de-energizes one after another as each opposite winding is polarized as north and south. As soon as we have the windings energized, the rotor turns to align itself with these charged windings. One of the Hall sensor detects the rotor have turned 60 degrees, and it de-energizes the specific coil and energizes the next one in the sequence, which again causes the rotor to turn 60 degrees more. This process keeps on rotating and keeps on going on, and we obtain voltage from 3 coils, as we can see in this plot here. We can see that one winding A is de-energized, the other winding A will be energized, and then the winding C, and the process will repeat. Hence, it takes total of 6 steps in total for the rotor to complete one electrical cycle of 360 degree. Through mathematical modeling and analysis of the circuit, we can obtain the following characteristic equations for the motor, which tells us the relationship between the torque induced by the motor and the speed of the motor. We can see that for the most part within the curve, the torque of the motor remains constant for varying speed of the motor depending upon the load. But there is a saturation point beyond which any increase in the speed of the rotor will cause sharply decrease in the induced torque. Hence, we can conclude from the graph that BLDC can be employed for high torque application for vast range of speeds, such as applications of escalators, drones, and electric braking in electric cars. Moving on to the applications of the BLDC, they are employed for high torque. Usually, primarily they were used in computer hard drives and DVD players for this reason, for the reason that I mentioned above. They are also used in modern day electrical cars and bicycles, for efficient braking mechanism and regenerative braking. Since in electrical cars the mechanical brake might damage the motor, so instead of that the electrical brakes are employed through BLDC. Other than BLDC, Other than that, BLDCs are vastly used in industrial robots and CNC machines as well because of the precision and position control due to feedback mechanism by the Hall sensor. High torque also make them an ideal choice in water pumps or power pumps and fast fans, as well as washing machines and other such devices. In this presentation, we saw uh, that BLDCs are a great choice for applications with high torque through analysis of its characteristic curve. We also saw its various application in control systems because of their precision and position and speed. We also saw the efficiency in comparison to the normal DC motor. That the BLDC motors are employed vastly in modern day machines and their scope is expanding as well. But one factor or drawback is the cost of BLDC. They usually are expensive due to inefficient technology used in it, but as the time is passing, they are becoming more common and cheaper, and therefore, thus in the few coming years, thus in the coming year, we may expect the role of BLDC to increase compared to now as well. And on that note, I would like to end my presentation. These are the references for the content that I have used for my presentation and the paper as well. And with that, I would like to thank you for listening to my presentation. If you have any question, please let me know via email mentioned here. So Allah Hafiz for now and take care.